Okay, so couple announcement before we get started today. I think I regretted all the lab assignment except the midterm exam. I was trying to do that on the airplane last night, but uh, didn't have enough time to go through. So we finish it today or this weekend, and I will post the sample solutions online. Do you guys finish all the questions? Okay. If you have any concern, let me know. But I haven't looked at it yet, so I don't know how everyone's doing. But we see. I will we go through that next week if needed. If everyone is doing well, that's fine. If like everyone is not doing well, then I will try to go over there on Monday. And I just posted lab 6. Literally just finished it this morning, so you can go through the slides. I think most of those we already cover in the previous lectures. So now if you see something like this in your mind, you should know how to do it. I mean, but you need to write code. But I mean, if you look at the interface, you know each component, what is that, and then just go back to the example. Should not be too difficult. Again, if you have any issues, just let me know. But those are pretty basic one. So this is about lab 6. I have not posted on Canvas yet, but it's on the website. I will post it on Canvas uh, after class. So this is about lab 6, and we might have another 1 or 2 labs about Google Engine, and then you'll be PostGIS. Okay, so maybe we spend another 2 weeks, 2 to 3 weeks on Google Engine, and then the last couple of weeks we'll be covering the spatial database. So this is another one, and so earlier you guys mentioned I think the EFA first engine on domain name I got the EFA or something. No, this one. What the engine book? Yeah, this one here. So if you type Earth engine book, yeah, mine is like in here, Google Gmap, but there's another one. So if you want to like learn more about Google Engine, so this is the book that was published last week, right before the conference. It's quite popular. Well, you can see a lot of this in here. You can download the entire book. So this one is, yeah, it's free. So the entire book, you can download the PDF in here. Just search Google Engine book, you should be able to download it, and it's open access. But it's using JavaScript. You should be able to convert JavaScript to Python if you want to. So this is a gigantic book, 1,210 pages. You see it. There are tons of applications you can do. And if you take a look at the chapter, so basically cover all the concepts and other stuff, and also a lot of like application, what kind of things you can do. So you can go through the chapter. I think I did contribute one chapter in here. 603. I cover how to, for example, how to create interactive web apps. So basically, we already cover a lot of those in the in Python. But also cover how to use JavaScript. If you want to go through that, try it out. But with Python, it's so much easier. So this basically show you 2 ways: either create using JavaScript or you can create using Python. And if you see some of those examples there, right? Something like this. So right now, if you look at this one, can you create one like this? Easy, right? Couple lines of code. And I think the lab assignments teach you exactly. So if you've gone through all the lab assignments, you should be able to do that. So it's pretty easy. Again, there are tons of things in here, like 1,200 pages and over I think 100 authors. So it's like a huge book contributed by the community. And it's free. You can download as a PDF or you can download as a EPUB format to do it on your cell phone. So this is a great resource. And so the other one I want to show you, where is it? Earth Engine documentation. So if you go to the Earth Engine documentation, the user guide, and scroll to find any examples. So you're gonna see like JavaScript and the Python collect. Not all of them have all the collect examples yet, but if it does, and there's at the top here, it shows you Python setup. It is. So now it's using gmap. So all the example, but you will see it's using import gmap.core gmap. You can just use import gmap like if you're using that. The reason for this is so gmap has a lot of functionality. The Google Earth Engine team can only support the core stuff. So right now, basically this one makes it easy for them to help maintain and develop. But for you guys, you just import gmap, nothing changed. Okay. The only difference right now is that we are trying to use the convention add underscore layer. We have been using like add uppercase layer. So this one's called camel case. This one is called snake case. So previously, the reason we did the camel case like this is to make it similar with the JavaScript, so that if users already know JavaScript, they can easily understand what is for Python. But now we're following the Python convention. So for Python, if you're naming a variable, usually we use lowercase. We don't name a variable uppercase. But in some of the example, we use the uppercase M. That's fine, but for users don't know Geospatial coming from Python, they will see, this weird. Why you name this variable like uppercase M, something like that. So now we're trying to basically revamp, and then so going forward, it's up to you. You can still use like uppercase M and equal something, but usually we do like lowercase m equal to gmap.map or something, and then use add underscore layer. So sometimes for some of the sample example I give to you, it might be one or two ways. So sometimes I use uppercase, sometimes I use lowercase. Either one is fine. Okay, so just don't get confused like why you do this. There's a reason behind. If you need more information, let me know. So again, just continue to use import gmap. You don't need to use like the core. The only reason is to because gmap now separated. So if you go to the source code, I can quickly show you here. If you go to gmap, and if you scroll down, so there's like core module. So this one actually is developed by the Google Engine team, and gmap built on top of this one. So it's kind of complicated, but just wanted to show that you know the history. So now if you go to all the Google Engine documentations, gmap is there. So if you click the setup and like this, but of course you need to create a map, like something map equal to gmap.map, and then you create a map. It's able to see that. And there's also a display, something like this, display, and then the map. Technically, you don't have to do that. You just type the variable name. So the display function comes from IPython. Let me show you what is this. So if I come back to here, right, I copy this example, and then I can go to somewhere. Okay, so just do this. Import. Did I recreate something? 1 second. I might remove the environment. Something conda. It's like a week ago, so I forgot what I did. It might be because I removed the gmap package. Is gmap here? Okay, so I just need to install it. 1 second. So Mamba install. Oh, by the way, so I recommend that if you install gmap on a local computer, try to update it, because there are a lot of changes in the last couple weeks. So try to reinstall it. You can Mamba update gmap, or in this case, I don't install it yet, so I just like this. Because I can see that from your lab assignment, the interface are very different. The reason because some of the things have changed during the past week or two. So try to just use Mamba update gmap, or pip install hyphen uppercase u update. Okay, then you should be able to use the latest version. If something is broken, just remove the contact environment and then just reinstall everything and start from scratch. So it's a good practice to, from time to time, every couple months, just create a brand new one and then just reinstall everything. So in that way, you don't have like sometimes dependency change, something like might be broken. Yeah, I will take it, install, and then I can show you the website. So here, for today, we're gonna cover a little bit more about the analysis. So last time, in the last video, I think I covered this one, like Earth engine reduction. So show you how to reduce image collection to image, or reduce a local image band to one band, or reduce feature collection column into a number or some statistical number, something like that. And we also covered the zonal statistics, right? Did we? Yeah, we already covered this. And so create coordinated grids. This one you can check that we don't have time to cover. I think I will talk about some of these we probably don't have time to cover the classification, so you guys can go straight if you to learn more about some of the statistical stuff. And I think there's one thing I want to cover. So the map, for example, image count. This one is actually quite useful. If you're doing remote sensing, sometimes you might see this one on some of the publications. It's a useful one that I want to quickly go through that one. So let me make sure it's installed. What? That's weird. It says install, but it's actually not there. Yeah, I don't see it here. Something is weird. Let me just pip install gmap so hope it works. So the latest one should be 2019.0. Usually I don't recommend using pip. Sometimes gmap might be broken or ipylib might be broken. So let's restart the kernel and try again. And see if it works. Yeah. Okay, nice. So it works. And I'm gonna skip to the map image count here just to quickly show you what it is. So let me run the code just to show you countries. So there is a function here. Gmap is a function called image count. This one might be a little bit slow. The data layer might take some time to come out. So the image count essentially is giving a time series of a collection of images, and it's gonna tell you at each pixel location how many images are available. So you can map, for example, the images available for an entire image collection. It's not coming out yet. It might be pretty slow, but on the in here, right, you can see that. And this is probably more than 60, I think. So what this one is doing is that we are pointing to the Landsat 8 image collection, and then we use the gmap.image count, passing the image collection. And then if you don't pass in a region, you will just do it at the global scale. And then start day and the end day. So this is basically for the year of 2021. And then because we don't pass in a region, so clip equal to false. If you look at the map, let me see here. Take a look at this. So can you like interpret what does this map mean? So we have a color bar here ranging from 0 all the way to 60 Landsat image count. So if you see from, it doesn't show up. This is pretty slow because there are will be millions of images in there. You can just use the collection doc size. You can figure how many. But why it looks like this? You know? Uh, do you see some patterns over there? Do you understand why it looks like this? So what does this one? What does this really mean here? Landscape image count. Or it doesn't have to be landscape. It can be anything. So what does this mean is at each pixel location, it tells you how many images are available. Basically, how many images cover this pixel. And why it looks like this. It's the orbit, so-called the orbit of flight path. So basically, for example, from the um, south to the north, for example, you can like orbit like this. So go up and down, but you live with some offset. So between these flight paths, there's some like overlap, a little bit overlap. So in those overlap locations, you will see this red color because it has more images. So you see the pattern, right? Looks like this because the Earth rotates, right? So when the satellite orbiting from the south to the north, it will go like this. So the Earth will rotate. So it's not like, that's why it doesn't look like vertical. I think if I show you the image at the beginning, you probably know what I'm talking about. Is it here? Look like this, right? So all the Landsat images look like this. Why? Because it's from the south to the north, from the north to the south. It's actually when you're rotating. So when you're taking the imagery, the Earth is already rotate. So when you're taking an image, it's not like a rectangle. It will be looks like this oblique. So think about here, one image, and then so it's continue. There will be another image above that, and there will be detail over that, and another one, another one, another one. So that's why it looks like this. And then between the fly paths, there's some slide over there. And this is exactly what it looks like after you plot all the stuff together. And some of the journal publication, all the papers, we show a map like this, showing you, for example, how many images are actually available. So in this one here, why this area is like all red? What's this? What's this area? North Pole? Yeah, because like the pole is just one point, right? So every time you go over, you cover. So the northern part we have a higher coverage because basically it gets narrower and narrower, right? And then you're gonna cover a lot. But in the tropical region, you see the blue color because it lays coverage. So it doesn't have a lot of overlap because it has a large area to cover. So that's why it's like only a couple images in 1 year. But for the polar region, you can think about it's gonna cover all the time. So it has a tons more images. And the pattern looks like this. So just try to understand why it is this, because fly paths over there, the vertical over there or horizontal also have some slight over there. And that's why somewhere in here, right, you see all the red color, that means it's going to cover multiple times, right? Pretty cool. So this, under the hood, this one has millions of images. It's a bit slow in here. You might need to wait for it to show up, but it doesn't matter how many images you, either it's Landsat, Sentinel, whatever. You want to find out, for example, how many images were acquired during the year for a specific satellite. You can just use this function. If you want to find out specifically how many, I can just try out. So collection dot size, hit enter. It might be very slow, so don't try to run this one on a large image collection. Sometimes it might take you a while because you need to look through all the images. And if you want to get a rough idea about for this satellite sensor, how many images were acquired during a year, a specific year, then just whatever image collection you have, and then just use collection doc size. Of course, you can also do a filter. Oh, I think I did. No, this is no good because I'm basically calculating the size of the entire image collection rather than just 2021. So this is going to be even slower. So you can take this one. I think is definitely millions of images, at least over a billion. It might never return. So it's better to maybe let's try this, and then I'm gonna do filter date. Yeah, it's going to stack. So don't do that for an entire collection. This is going to take forever. I'm gonna remove that. So if you want to guess like how many images Landsat 8 will acquire during a year, anyone have an idea? So what's the revisit temporal frequency for Landsat 8? How many images will require? For example, Knoxville, how long can you get one Landsat 8 imagery? How long? 16 days. Yeah, I like that. 22. So every month you get roughly uh 2 images. And so let's figure it out. Just to show you here, we need to filter. Again, don't try to get the entire one. That one is just way too much. So I'm going to just filter the date. You can also filter bounds to get like exactly how many. But in this case, I'm just going to show this one. I hope it's not too long. So usually if you filter narrow down a little bit, you'll be a little faster. But if you're trying to, for example, trying to count how many people in the world, like individual one, it's gonna take you a while, even though it's called cloud computing. So how many? 155,000. Yeah, 155,000 per year. So when was Landsat 8 launched? 2013. So 2013. So now you think how many years? Almost 10 years. Multiple by 10 is 1.5 million. So like I said, there are millions of images. So don't try to do that for the entire collection. But it's for one location, that's fine. And so the map that we created earlier is processing 155 images. So that's a huge number. Anyway, try this one for any image collection. Like it doesn't have to be Landsat. Any image collection, and you will figure out how many images at each location. You see now it's much faster because Google Sensing cached the result somewhere on their server, so it's faster. But you need when you zoom in, you need to wait a little bit. Right now it's a little bit fuzzy, so it's not so good yet. Okay, so that's about the image count and also create cloud-free imagery. So Google Sensing has a function called algorithms.landsat.simple composite. So this one is a specific function that help you create cloud-free mosaic for Landsat data. This is not for Sentinel-2, but the input data you'll be, for example, this is you can just passing for the entire image collection and then tell you tell Google Sensing, okay, I want the imagery for 2021, right? For the entire image collection, and then call this function. In general, this one is better than using the median. So the median, because you might end up with a lot of cloud, so the imagery is not as good as you use the lens simple composite, because the simple composite takes the cloud into consideration. So if you want to see the documentation, I can shift tab, and it's going to show you what does it do. So it's using the top of atmosphere. You see this one here, T1, not the T1 SR. And let me see if I can show you the differences. So I'm going to copy this one, come back to here, but in general, I can just use, like in the past, this is what we use, okay? So median. So that means you're taking the entire Google Sensing Landsat 8 image collection, right? We just did it earlier. How many images? 155K. And you take the median, and then we can see what's the differences. Oops. Oh, median, median, right? And this compare the differences. Oh, okay. So because this one I think the value is between like 0 to, let's try 3000, because the pixel value is different. Still no? Maybe 30,000. Okay. You see this one, and then pay close attention compared to this one. Which one is better? Right. So the reason is the median function takes all the images, while the length algorithm simple composite, this one takes the cloud into consideration. If it's cloudy, it doesn't use it. So it's more like automatic function that can help you create cloud-free mosaic. Although in all the lab assignment we've done in the past, I asked you, okay, create a cloud-free mosaic for somewhere. You just take the median function. Most of the time it's fine, but if you if your images has a narrow, smaller sample size, you're gonna end up with a lot of cloud. But in general, if you use the simple composite, you'll be better, right? So if you zoom out, you see some of those in the ocean like have cloud. Why you have more cloud on the ocean compared to the land? This is not web, this is cloud. Assuming this is cloud. Right, in general, ocean has more cloud than the land. Why? Yeah, the water comes out, evaporate, and then you're gonna form cloud and then come back some to the ocean. Yeah, that's the reason. So you see here, but like I said, if I zoom out, this is going to be so much better. So in the future, if you need to create some like cloud-free mosaic, especially for Lancet, use this way. It's so much better. Even if you zoom out to the global scale, it's really cloud-free. This one is really cloud-free. So try to utilize this function if you need to create something. You see, it's so much nicer. For this function, like, oh, then you will end up with like black. It's going to mask out. So I think depends on, you can specify. I believe you can specify parameter like percentile or something. For example here, collection, the percentile value when compositing each band. So I think by default is 50, but they also have the cloud score range. Like what's the cloud score range that you accept? So you can customize it. I think this. Let me show you the help documentation. But usually you can just use the default one unless you have something very precise, then you can try to change it. So here, the percentile is 50, kind of similar to the median, except the reason is better because it has the cloud score range. It's using cloud images with cloud coverage less than 10%, rather than using everything. So this one basically greatly reduce the number of images being used when you are creating a cloud composite. Kind of this is the a shortcut. Technically, you can also edit image to create a collection and then talk filter, right? And then you can edit filters, the EQ or GT, ALT, and then the cloud cover is less than 10%. You can also do that. So it's up to you, but usually this is a little bit better. But keep in mind, this one it's only applicable to the top of atmosphere, so you cannot use in the surface reflectance. For example, T1 SR something. So let me show you quickly about the differences. So if I go to the data set and then scroll down, right, this one is Lancet. And so we're talking about Lancet 8 here. Lancet 8 has a couple data products. So you have the raw images, top of the atmosphere, and also the surface reflectance. So surface reflectance, you can see T1 underscore L2. The top of the atmosphere is TOA. Oh, I think it's the raw image. So the raw image, original. So it has not been atmospheric corrected. So you can apply that function apply to this raw image things. But if you use other collections, just like dot filter, and then the filter the cloud cover is less than, for example, 10%. When you create it, the image should be so much better. Okay, so now you should be able to find any images you like. You should be able to find a subset of images and then create a cloud free. Kind of like you're watching a movie and then you twin the color or you turn on the color mode, whatever you use the monitor, just to get a good view of all the images. So that's for Landsat, but you can do that for the Sentinel-2 if you want to. Okay, so that's about the two things I want to show you, like image count for any the pixel location and also the cloud free mosaic. Next, let's go through some of this. We will not have a lab on this one, but just to show you, it might be helpful for you. So if you have any GeoJSON, okay, there's a function called GeoJSON to DF, and then you can get the attribute table. So this is a country GeoJSON somewhere on GitHub, and then I'm going to basically open the attribute table to see what is in there. And you can return this one as a pandas data frame. That means basically it's an attribute table. With that, you can create some plot. So let me show you here what it looks like. At least it should have the. So what this one is doing is, okay, so you have a table. The counterpart will be, you open the Excel and then select column and then create a bar plot for that column. But right now we're doing that programmatically using Python and gmap. So there's a so-called the bar chart, okay? And within there, you can pass in the data and the X and Y. So what this one is doing here, we have countries, right? In this name column. And we also have a population here, POPEXT, population estimate for each country. And what we're trying to do here is to create a country and then rank them by population size. Okay, one line of code. But you can customize, you can add the label, you can add the X and Y label. So again, X axis is the name of the country, Y axis is the population, and then the label, X label is this one here, this country, and then population, so the Y label. Whether you want to descending or not, okay, even though descending is going to be from the by row. Okay, we're descending because we want to show the population the largest to the lowest, and how many rows, so basically how many countries you're gonna show. Otherwise it may be overwhelming. You're gonna have all the countries, so you're gonna have it's much longer. And the title, world population here, and then the height is how high you want the plot to be. And the last one is the layout, the title. So basically, where do you want the title location? So basically here we wrap in the x-axis is in the middle, and the y-axis is 0.85. So that's why it's at the top. If you want to move that down a little bit, for example, I can maybe try 65, like 0.65. Then you're going to move down a little bit. So if you run this one again, you see here. So basically, the layout shows you if you want to change the title, like the center of the title. So X is, so basically 50%. So 50% X will be in the middle, right? 65%. So the height is from, I believe it from here to here, roughly like somewhere here. So you can customize if you want. And I can turn on, for example, the descending to, or by default it's true, but you can, I think you can turn to maybe false. If it doesn't work, it's a bug. It should, okay. Like from the basically the reverse. Low is first, and then, oh no. Oh, it's only the top. I think only get the first 30 countries. So for example, you have this spreadsheet, right? And if you are descending equal to false, you're going to grab, depending on how many max number of rows you have, it's just going to get 30, the first 30 rows, and then just do the ascending. So if you want more, you can change this number. So let me turn this one. If you don't do it, it will probably make up the entire one. So it will look like this. Right. So you have your mouse, pretty cool, right? But all the other countries pretty very tiny, so it's not very useful to do all of them. Maybe 50, a little bit better. Right. So the data set is a little bit outdated. I believe India already took over as the most populous country, right? And this data is a little bit outdated. But anyway, that shows you how to create a bar chart. Of course, you're welcome to use Excel to do that. But at least now in Python, there's one simple way. So you can pass a data frame, or you can just pass in a CSV. If you have a CSV on your computer, it's just data equal to the file passed to the CSV, and then you can do that. So you can create bar plot, or you can create pie chart. So I'm going to run this one. You see, pretty cool, right? One line of code. You probably can also do this in Excel, but I think this looks nicer. You can have a mouse. You can also see that interactively. So what this one is doing is we are doing the same thing, creating using the name column, and this one use names and value. I think you can use multiple columns, but we're just using the name column as the x-axis and the value with the population. So what this one is doing is taking that column, all the countries. So you can think about the global population, and look at this, like the other, basically, we only showing you the top 30 countries, and all other countries is categorized as other country. So what this one is showing you, for example, China takes about 18.7% of the global population, and India 70.4%, then the US 4.4%. All the other countries is 22.7%. If sometimes you don't want the other category, you just want the top 30 countries, you can click here, you will hide that category. You see? So if you just say, okay, the top 30 countries, then China is about 1/4 of the countries. If I turn it on, right, you can add and remove a certain country if you want to. So it's pretty nice. Right. So you can use this to do any data you want. So give a CSV if there's some numbers, for example, population. It can be what else? Anything you deal with count. Sometimes you want to get a percentage, then you can do it like this way. And you can do it for county, for state. As long as that column is numerical value, you need to add them all up and then just divide it. So that's why you get the percentage. Make sense? And the other one, the CSV called live exp, so a live expectancy. Basically, how long do people live in a certain area? So if you run this one just to show you what it looks like. So we have this table by country, and then you also have continent. This is Australia, and I'm going to show you life expectancy, the trend, right? So in 1952, in Australia, the life expectancy is 69.12 years. In 1972, it gets a whole lot better, right? So now, because in the past, the medical and all the stuff are not that good. So right now, because of technology or advancement, people live longer. So if you want to show, like, if you have a table, if a spreadsheet showing the data like that, and what this one is doing here is, think about, we're opening the CSV, and then we're converting to a data frame. This one shows you basically like a subset of the data. So we're only focusing on the countries in oceanic continent. So basically, just I think it's Australia. What other country? New Zealand. So there are only 2 countries in there. And then the X is year, right? Because we want to show the trend, overall trend. And then the Y is the life expectancy. And then the color, because you want to different country, you want to show different color. X label is here, this one. Y is the life expectancy. Okay. And the title is here, country. The height, the markers, whether you want to show the markers. The marker basically have the point, the data point. Right? Pretty cool. One line of code. And if you want to try like other countries, you can certainly do that. So I can maybe new block in here. But for other country, probably it's too many because they might be like overwhelming. Oh, it's only 2 countries? Oh, because I already selected it. So now if I want, I can, let's say, okay, you want to map the countries in North America, see how the life expectancy changes. So I can do it in here. And then you see Afghanistan, continent. It'll be hard to actually to, let me see what's the name for North America. So continent or TIN continent. NT, okay, continent, right? It has a lot in here. So Asia, Africa, you can try the unique. You can see like what's the value. Okay, this is Americas, no North America. So if you want, you can select America. So here I'm gonna grab this one, passing to Oceania, to America. Probably it's too many. The plot will be overwhelming. But if you want to see it, yeah, you can certainly do it. You see? So the overall chain for the life expectancy is the US here. Where is it? Okay, here, right? This line. Oh, this is Haiti. I think US should be somewhere pretty high. Yeah, somewhere here, right? It's actually at the top, right? So you can clearly see like how long do people live on average. What's the top one? Canada, okay. Interesting. So if you want to live longer, move to Canada. I mean, you have a high probability to live longer. A little bit more. So it's like life expectancy is 80 years old, like on average. So try to live longer than 80 years. Otherwise, you are below average. Right? Pretty cool, right? One line of code, so you can actually plot data. So if you have something like with one column, it's like the category, countries, states, whatever, and the other column is that you have multiple years and you have the train. So you, oh no, this one is like 3 columns. You are dealing with 3 columns. You are dealing with the continent, you are dealing with the year, and then you're dealing with the number, right? So similarly, if I'm trying to ask you, okay, try to create a plot to show the income changes for every county in Tennessee. If you have the data, you can do that, right? So you'll be the county, and then the year, the income, right? So you are dealing with 3 columns data. So again, go back to here, right? Country, a continent, and then the country. Oh, actually 4 columns. We're dealing with 4 columns, right? We're dealing with what? No, 3 columns. Sorry. The first one, the continent, just to select the data frame. And once you have the data frame, then you are dealing with just the country, the year, life expectancy. Of course, you can also do the population. So in here, right, the population shows you like every year what's the population. So this will be interesting to see. So if I try to do POP, to do the same thing in here, right, rather than life expectancy, I'm gonna do POP. Okay, so let's see if it works. Yeah, you see, it's just one minor change. Look at this. Who is the top one? What's this? America, right? You can see the population like increase. Stay not steady. I think it's like going up quite significantly from year 1952 all the way to right now, right? More than double, almost double in 60 years. Other countries, a little bit. For the next one, Brazil. What's the third? Mexico, okay. Interesting. Canada actually is pretty low. Huh. Interesting. Colombia, Canada. Huh. We expect Canada to be much larger. Yeah, title. What's the title? Oh yeah, this one can change, but it doesn't matter. I'm talking about the trend, right? So Canada actually doesn't increase a whole lot. I saw like lot of people migrate, but this is only like up to 20. What's the year? 2007. So it might increase a lot more the past couple years. I would expect to be much higher. But I mean, the life expectancy is much higher, so people should move there to live longer. Anyway, so this is how you. This one has nothing to do with Google Engine. This is more like general. If you have a spreadsheet, you want to create some bar plot, pie chart, or even line chart, you can do it like this. One I call. And also engine chart object. You can also do. So if you want to create plot for Google Engine object, use this module. Import gmap chart is this one. And so right now, if you see here, we are trying to, we have a quiz collection, and it's called equal regions. So in here, let me show you what's inside there. Okay, I'm gonna click this one. Oops, click here to show you the object. Wait again, so they can see the content. So basically, we have 3 polygons in here. For each polygon, this is the attribute table showing you like there are tons of columns available. If you want, you can show the E to DF, just to show what's inside. So you have 3 polygons, right? And each polygon, you have these attribute columns, starting from 1 all the way to this. So basically, for example, this is the temperature for every month, average temperature for every month from January, February, blah 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 blah. And similar to the population we saw you earlier, right? You have the time series. You want to create a plot. You can do it like this way. So just to show you what it looks like. Options. I don't have time to go through all the details, but I just want to show you what it is, right? Pretty cool. That's a couple lines code. So what this one is showing you is we have 3 polygons. Each polygon is in a different land cover type, right? Desert, forest, and grassland. And this shows you basically the average temperature throughout a year for different land cover. So for desert, right, you see it's much a little bit higher. Forest a little bit lower, right? And then grassland. So you can see every month what's the average temperature in that location. So certainly during the summer, like the temperature is much higher compared to the others. So you can create this kind of plot easily if you have some data organized in this way, right? By month. So basically, this is each land cover type, and this is by monthly. So you can see the trend, overall trend for each land cover. There are a couple more examples. We don't have time to go through that, but try to that. There's also histogram and use some of those. I don't think we have a lab for this one, but we might have a quiz. I give you a spreadsheet, ask you to create something like this. So go through the examples, and we might have a quiz next Monday. Okay, so prepare. I'm gonna give you something and then ask you to create a plot, for example, like this. All right. So see you next week.